this is where we really start to earn our money here. So I'm going to, these two questions, they look tough. They have different bases, a lot going on in there. And in fact, they are tough. So when we encounter more difficult questions where it's a matter of different bases, maybe a common base, base 10, is the best way forward here. I'm going to take a look at this bottom option, and what I'm going to do is I'm going to choose to solve for x, and I'm going to use the common logarithm. So very simply, I'm just going to not make a mistake, I'm hoping. So if I take common logs of both sides, and I'm just going to change up the way that I write this ever so slightly to remind myself that 6 is being multiplied to 3 to the power of x minus 4. And right now is on the left-hand side, I'm going to use the product law for logs. And the log of a product is really the sum of the log of the factors. So this ends up being log of 6 plus the log of 3 to the power of x minus 4 is equal to, now on the right-hand side, I'm going to choose to simplify this by using the power law, and this will be 2 to the power of x log 5. So common logs really work well here, and what I'm going to do is I'm going to perhaps deal with this. Not everything is in logarithmic form. We still have an exponent, that x minus 4. So really this is x minus 4. I'm going to put that in brackets because it is a binomial, times log 3 is equal to 2x log 5. And fair enough. So everything, well, I'm almost ready for algebraic manipulation. I'm going to keep in mind that this is a binomial, so you'll need to multiply it out. So on the left-hand side, I get log 6 plus x times log 3 minus 4 times log 3 is equal to 2x log 5. Or if you want, you can call that x 2 log 5 or whatever. Regardless, now I think I'm ready for algebraic manipulation. I just want to make sure that I am indeed progressing correctly, and it looks like I am. So everything with an x, I'm going to move to the right-hand or left-hand side here. So this is really x log 3. I'm going to subtract 2x log 5 to both sides, and that is going to be equal to, I'm going to subtract log 6 to both sides, so minus log 6, and I'm going to subtract, or sorry, add 4 log 3 to both sides. And that's the expression I get. Now, the next step I'm going to take is I'm going to factor out x from this expression. One thing you need to know is that log 3 is just a constant. So really, if I factor out x log 3 minus 2 log 5 is equal to negative log 6 plus 4 log 3. Now the hardest thing is, keep in mind that these are just constants. They're big and ugly looking, I agree, but they are just constants. So if I want to isolate for x, so x is going to be equal to, I'm going to divide both sides by the constant on the left-hand side. So what I end up with is minus log 6 plus 4 log 3 is, or divided by log 3 minus 2 log 5, and that is the algebraic manipulation for this. So what is x? Well, x is going to be equal to negative log 6 plus 4 log 3 divided by log 3 minus 2 log 5. And if you do that in your calculator, now those are all common logs, what we get is x is going to be equal to negative 1.228. See? Told you you're going to have to earn your money here. Yikes. That was intense. let's go to the one above it now. I wish I could tell you this one's better. Simply not. All right, so my first move again is I'm going to take common logs to both sides. So log 17x plus 4 is equal to the common log of 19 3x minus 2. And what I'm going to do now is, this is a little bit difficult, but now I'm going to use the power law for exponents. So really, this is x plus 4 times the log of 17. So I'm just going to maybe put those in brackets to ensure, but this is one quantity, whereas this is a binomial. Is equal to 3x minus 2, so this is a binomial again, times the log of 19. Now, I just want to make sure that I have my notes here, because it is tough work. I'm not going to lie to you guys. So what I'm going to do is I'm going to make sure I'm multiplying the binomials by the monomials, and what I get is x times the log of 17 plus 4 times the log of 17 is equal to 3x times the log of 19 minus 2 times the log of 19. Now I'm sure hoping I'm doing this correct, because I am nervous. This is a big, ugly monster. Let's keep in mind what we're doing though. This is just a constant. This is just a constant. They're constants that you're going to have to get used to. So I'm going to move everything with an x over to the left-hand side. So what I get is x times the log of 17 minus 3x times the log of 19, so I simply subtracted that quantity to both sides, is equal to negative 2 times the log of 19, subtract the log, or subtract 4 log 17. So I just subtracted that to both sides as well. Now I'm almost done, I believe. I'm sure hoping I'm almost done. And I'm going to factor out x from the expression on the left-hand side. So x is equal to log 17 minus 3 times the log of 19. Now remember, factoring out is very similar to dividing, so keep that in mind. Is equal to, now I'm just going to keep this expression as it stands. So I'm almost done. Now I'm going to try to cram my work into this space, because it's really hard to move up. You can take it out. So I'm going to divide both sides by the constant on the left-hand side. So x is going to be equal to negative 2 log 19 minus 4 times the log of 17, all divided by the log of 17 minus 3, the log of 19. Wow. And I'm going to take out my calculator to find out that value, and what I get is x is going to be approximately 2.807. This was a fairly intense couple of questions here, and no doubt they needed some work all by themselves. You have to get used to the notion that what